Hello, and welcome to The Confident Commit, the podcast for anyone who wants to join the conversation on how to deliver software better and faster.
If you're looking to build a trusted ship, tune in, let's confidently commit.
I'm your host, Rob Zoomer, CTO of CircleCI, the industry leader in all things CI and CD. Today, I'm joined by Carolyn Mooney, CEO of Nextmv, a decision ops platform. And we're going to spend a little bit of time at the beginning just understanding what that is. But first of all, I'm super excited to have you here today, Carolyn. Thanks so much for joining me.
Yeah, thanks, Rob. And Happy New Year. Excited to kick off the year with you.
Yes. Welcome to 2024, people. Although it might be a little into 2024 by the time you hear this, but we'll roll with it. So let's kick things off. I mean, we met a little while back. We were having a conversation about AI, sort of all things AI. And I think 2023 was the year where generative AI like sucked all the oxygen out of the room from an AI conversation perspective. But anybody who's been in the space for any period of time, which is a very, very long time, right, in terms of the whole arc of this tech, knows there's more to it. There are other branches. There are other sort of interesting things that folks have done. And generative AI in particular, like it's getting a lot of use and a lot of application, but it's a very sort of blunt instrument, right? It's a general purpose tool. So to kick things off for folks who don't know, I think we're going to use the words decision science, decision operations. Can you tell us just a little bit about, what that is and a little more specifically, what kinds of problems you're trying to solve within that discipline?
Yeah, absolutely. And maybe I'll start with, there's been a lot of buzz around Gen AI, and for good reason, right? A lot of, folks that were not necessarily in technology got to get their hands on an AI technology, right? And so I think that was a really big part of why it got so much fanfare, in the last year. And I think when I think about AI, I actually think about AI a little bit more broadly, right? So when people talk about Gen AI, they're typically talking about a conversational version of AI, right? You as a human are kind of interacting with data and systems. And that's where a lot of the LLMs have come from and things like that. The reality is that there's a lot of different decision-making technology under the AI umbrella. And so whether you're doing language processing or image processing, right? Or in our case, you're creating plans out of large-scale data sets, in the optimization and simulation realm. These are all parts of AI. And I like to think about decision science as really the discipline behind applying AI to different problems for your business, right? And so decision science has been around for a long time, right? If you even look back in prior world wars and things like that, that's where they were using things like optimization to make plans for the military, right? On large scale data sets. And so we focus a lot on optimization as one of our core types of AI technologies, and really where you're applying that is in the space of either sequencing tasks for humans or machines, or for allocating tasks to humans or machines. So something like creating schedules for a retail business, right, for all of their employees. Something like buying inventory or purchase orders and deciding what inventory to put where. Those could be things that they're solving kind of in the retail industry. You got things in finance like portfolio optimization for deciding where to allocate your funds, right, to different to different investments or stocks, and even network design, right? So it kind of spans a lot of different areas. And then Ryan, my co-founder, and I spent a lot of time in logistics, right? So creating schedules for drivers and creating routes for those drivers in real time for meal delivery at Grubhub. So it spans a lot of different domains, but I like to think about it as that sequencing of tasks or allocation of tasks is really where we spend a lot of time.
Yeah, I mean, I think that's the generalization is good, and I think you mentioned you were at, I can't remember which one was which, but you were at Zoomer, Grubhub, very sort of driver oriented, which I think a lot of people can get their heads around, right? I was trying to think of
it's very tactical, right? That my delivery driver got assigned my order, right, when they drop it off at my house. So
right, exactly, or people take Lyft and Uber and these sorts of things, and that sort of it's not hard to imagine. I think that there's a lot of real value for businesses in optimizing those things, right? I mean, we talk about the traveling salesperson as the original problem that every software developer
that everybody knows,
maybe not CS 101, but soon. Yeah, exactly. And so is it really the same thing generalized? Is is it really so generalizable as that problem that we think about, or are there sort of like, as you move across different domains, are there sort of specific things that you need to solve for as you get into other types of decision making?
Yeah, so I like to think about like it as solving for a particular KPI. So if you think about for the TSP problem, right, the traveling salesperson, you're typically solving for like minimum time on road, right, or minimum travel distance, right, between like the different stops. In other contexts, you may be solving to like minimize cost of handling inventory at a particular distribution center or with a particular carrier. And so it just kind of depends on what you're looking at, where the data changes, but the structure of the problem is somewhat similar, right? Where you are still trying to allocate drivers to tasks, right, which are those orders to go pick up, right? You could be doing the same thing, with machinery on a manufacturing floor, right? Where do I assign, right? How much volume do I assign to each of those machines, right, to process over the course of the day, and in what order? Right. And so the structure of the problem is somewhat similar, right? So this all kind of falls under that optimization domain. And really, I like to think about it as those large scale plans, right, for the operation, where if we were to sit here, we could do that problem on a small scale, right? But it gets to hundreds of drivers, thousands of orders, or it gets to millions of pieces of apparel that I need to put in just different distribution centers. That becomes like not tangible for me to do as a human operator. And also suboptimal, right? So you're leaving a lot of money on the table by having a human operator kind of piece that problem up into manageable chunks.
Yeah, that makes a ton. I mean, my first job out of college before I got into software was actually in manufacturing, and that was very like, it was all about. It wasn't the job that I did, but it was all, when is the truck coming in? What parts are we going to have? How can we, like, what should we put on the line right now? Like all of this sort of stuff, and a lot, and then something went wrong. Right, like a truck got stalled at the border or whatever, and therefore we didn't have that part.
Re-optimize or replan, right?
Right,
and yeah, exactly.
I'm pretty sure it was all in like Excel or possibly Lotus
Probably
123, just to date myself. But so I'm sure this would have been very useful. And then now running CI/CD, like we basically allocate machinery and to run our customers' jobs, right? So
even use it today. Yeah.
Right. We have a very I'll say small, but it's large but very specific version of this problem, I think, that we handle. So I can imagine anyone listening to this can see the thing in their business that they're trying to optimize where there's real value and return. So speaking of CI/CD, we talked a little bit about this before, but like as we shift into the AI space, as more people are integrating into their overall systems, not necessarily just code that they're writing every day, but data-driven components, let's call it, right? So let's say I have a decision operations tool, and maybe the tool itself isn't changing because I'm outsourcing it to someone like Nextmv, but my data is changing. Like, how do you think about sort of integrating, understanding what those changes do, and knowing that you're still getting good results for something that isn't necessarily changing code?
Yeah, I think there's a couple pieces there. So I'll probably start with just like kind of building these models in general and kind of putting them into a CI/CD workflow. I think is super important. So I've actually done a few talks in the past on decisions as code. So they should actually be codified and components that are in your software architecture and managed the same way as the rest of your software stack. And so what I mean by that is, typically this process around modeling, right, is a very mathematically heavy process, right? And so you may have like these data scientists or decision scientists working on formulating a math problem that represents your real world problem, right? And so that seems a little bit like disconnected from your software in a way because it's more of like a research oriented task. And what's happened as more and more of the data stack has come like into more real time, right, or more accessible to data science and decision science processes, that those systems have gone from research mode, where they are used for like strategic decisions on a monthly or maybe quarterly basis, to either daily decisions that are being driven off of those models, or even real time in the case of something like Uber, Lyft, right, Grubhub, et cetera. And I think that transition has like necessitated the software considerations to be like front and center. So Ryan and I actually wrote when we were at Grubhub about decisions being first class citizens in your software stack, and because of that, they need to meet some of the same rigor, right, as the rest of your software. And that's where I think CI/CD comes into play in a really big way, because you're not just testing the fact that the code itself works, right? So in other parts of the software stack, it's like, does it compile? Does it build? Does it execute on the data that I'm passing it in the way it's supposed to, right? At the scale it's supposed to, right? Those are all great questions to ask. But you also need to consider the quality of the data output in the decision science domain. And so that's I think where the nuance comes in with CI/CD specifically around like algorithm testing, and where we play a lot, with our decision ops platform is giving you some of the tools to do that integrated with your CI/CD workflow, right? So you should have those automated tests happening as you're adding new constraints to your model, as you're adding new KPIs to your model, et cetera.
So super fascinating, because one of the things that, like, we talked a little bit about Gen AI at the beginning, I think people are really struggling with as you get all the way out into sort of speech and sort of interactive dialogue is, how do I know what's good?
How do I know what's good? Yeah.
Do you have the same sort of problem from a decision perspective? I mean, you're trying to measure decision quality. What does it look like to know that the output is good?
Yeah, I think that's a really interesting question. And so typically in this space, there's competing interests. So if you think about a large scale marketplace where you're trying to allocate resources, like we're trying to make calls on like inventory optimization, right? You may have one side of your market really wants speed, right, and the other side of the market really wants efficiency, right? And efficiency usually comes at the cost of speed, right? And so you kind of have these trade offs. And what we've put in place is an ability to set like kind of acceptance thresholds, right? So maybe you're putting in a change to your model and you're expecting there to be a speed degradation, but a gain in efficiency. Okay, well, you need to represent those as maybe ranges of acceptable, quality changes. And so I think that's like where that nuance comes in with it's not just a binary, right, acceptance criteria. It's really a range of solutions. And so being able to kind of evaluate those ranges is really what we've been looking at a lot. And I think it's a really interesting question for LLMs. Like the quality decision for LLMs is, I think, a little bit more challenging because of the language processing aspect. For us, it's really KPI driven. So it's usually like a hard dollar value, right, or a hard time or things like that. So they're a little bit easier to measure. But they're dependent on upstream systems. So if you think about maybe a scheduling model, right, in the decision science domain is dependent on the forecast. So if you put in a forecast, the higher quality your forecast or the more knowledge you have about what's going to happen, the better those decisions are going to be, or the plans that are outputted from that scheduling model. And so there's some interesting interplay there where you kind of need to understand the predictive inputs, right, that are coming into the system as well.
And that whole thing now has me thinking about sort of feedback loops and control systems. Like,
it is. It's all that. I'm a systems engineer. It's all of it.
Amazing. So then you're taking, like, as the forecast is turning into known data, right? Like now you have more historical data. Do you then feed that back in to adjust, for the next cycle?
That's exactly right.
What sort of timeframes is that working on? Is that all instant?
So that could be, we typically like look at, it's like a windowed process normally, like, so it'll batch over a certain period of time. And so, maybe if you're doing a real-time system, you want to grab things that are happening in the last 30 seconds, right, or the last minute. But if you're doing a more tactical decision, like creating schedules, obviously you can't create schedules, this minute and show up tomorrow, show up the next minute, right? That doesn't really work. So it depends on your business need, right? And like how frequently you want to make that decision and then post the results, right, for your operation to go execute on. So for schedules, you might do those daily or weekly, something like that, maybe the cadence that you're actually running that on. But it does get back to the question you had about before about like, what if my code doesn't change? And that's the interesting part about these decision systems. The code may not change, like the model formulation may not change, but if the input data is changing significantly in terms of quality, the resultant decisions quality is changing. And so that's actually another reason why CI/CD is super important here, is because as your data is changing, you should be running consistent tests, right, on your decision models. So a good example of this is if you're a startup and your volume is growing like crazy, as a delivery company or something like that, you need to have current inputs that are from like the last couple of days tested against that model all the time to know that you're, maybe reaching a point where you're not handling good service levels anymore, right? Or you need more drivers, or you need different schedules, something like that.
now I'm super fascinated by trying to test a system like this, like running different scenarios or simulations. Like I'm not sure exactly how that works, but to your point, I think a lot of us who have done what I'm now calling traditional software development, it's like binary, right? We put in 1 and 1, we got 2 out the other side. Awesome. But not this like all these different possible scenarios that could play out. We had massive growth. We didn't have massive growth, those sorts of things. And so do you help folks build those kinds of test scenarios? Like how do you, for people who are sort of uninitiated, how does that work?
Yeah, exactly. So on our platform, you can essentially manage multiple versions of your model and then multiple endpoints for that model. So you can do different configurations that have, maybe optimized for different KPIs or have different balancing of optimizing for different KPIs. So if you want to balance between cost and efficiency, you can have both of those things in your value function, for example. And we also give an experiment framework that you can actually hook into your CI/CD. So we have a CLI tool, and the API for each model is unique for that app. We call them decision apps, right? So those apps all have their unique API that you can kick off experiments automatically as your code is changing. And so the idea is to get that algorithm development team into that same CI/CD workflow that the rest of your software team is in. And so that gives your stakeholders confidence that that model, right, is doing what you expect. You can surface results and share them, right? And so you get these nice printouts of I improved the value function or my KPI by X%, right? And it's significant. Like we think that's a good change. Or here are the underlying KPIs that I care about, like number of drivers on the road or number of people I scheduled, right? There's a number of priority folks that got their preferred schedule, right? Things like that. Things that matter kind of from like a experience perspective for either the consumers in your business or the workers in your business. Yeah.
Got it. And so I'm trying to figure out your customer a little bit in my head, and I could just ask you, so is it primarily the like data science team? Is it folks who work on algorithms and are building these sorts of, but then try to operationalize them, productionize them? Or is it sort of software developers saying, hey, what we really need is this, but we have no idea how to do it. So it would be great if we could get, or some mix. Like, how does that work?
Yeah, for sure. We actually sit right in the middle of the two. So you're not wrong on either front. When we were at Grubhub, we had both basically software teams and like algorithm development teams, either data scientists, decision scientists, folks. It's actually a large debate about what we call ourselves in this domain right now. But we had kind of both, and the reason we started Nextmv is actually because we felt like there wasn't actually a good technology stack for the two interacting. You had folks building the algorithm and maybe in like research mode or in like a Python Jupyter notebook, and then you had the software team trying to productionalize it, right? Deploy it, make sure it was scalable, make sure you could call it at the cadence you needed it to, right? Latency was good, all the things. And so like that was a really hard transition period, right? It's like getting it to the point where it was actually a service and an API that you could be calling behind your UIs or behind the rest of your backend system. So that is where we sit kind of in the middle of those two. We have like pieces of our workflow are more software oriented, right? To get those algorithm builders kind of into that workflow and not have to think about those specifics, right? They don't have to think about building an API around their model. They can worry just about the decision code itself, right? Or the decision model itself, and allows them to kind of accelerate through that workflow. And then we check a lot of the boxes for the software team so that they can integrate, these systems with other pieces of the stack.
Effectively by, I think you said already, treating
it as
an API.
Yeah, but it's like their unique API, which is really nice, right? It's like, I say it's like you can build your own SaaS app.
Yeah. And is it like a lot of, I realized we already went through the list, like many different problem spaces, many different types of organizations have these sorts of optimization problems. Are you finding folks realizing like, we're trying to build all this stuff, we've been doing it for a while, but we're trying to operationalize it and it's hard, and therefore we'd love to give that to an expert? Or is it, are you seeing more of the like, we're trying to start something and this is yet another discipline we'd have to figure out, but hey, look, we could, we could outsource that and not worry about that piece of the puzzle?
Yeah, it is definitely a split. I like to say there's like kind of this like decision maturity, like life cycle that happens at every company where people start with very manual decisions. And this does not depend on scale or size of company. They're like very large companies that are still making decisions in spreadsheets for some things, right? And then there are very small companies that are super automated, right, and are already doing everything in this kind of like service fashion. And so it just depends, right, on like kind of where you are on that life cycle. What your familiarity is. I think people are more and more familiar with this space. I think folks that are doing decision science is one of the top growing fields, actually. Decision science operations research is like one of the other underlying names for the academic side. And that is a really growing, discipline and job title, over the past couple of years. And I think that's driven by the fact that like there's more like data accessibility. People have built a lot of predictive models in the data science space. And I think the problem is that getting operators to take a predictive model that is very distribution based, like, oh, my forecast is maybe going to be somewhere between here and with this probability, and translating that into a schedule, right? There's like that missing piece, which is like, how do I actually take that predictive data and large scale data set and make it an operational plan? And so that's like why this space is becoming bigger, because more data is available for these types of decisions, I think, across a lot more companies. So we typically see, honestly, both, where people are trying to take something net new out of a manual to an automated fashion, and then also the operational side of it. In our space, there's a lot of solvers, what we call solvers, or fancy search engines. These search engines are searching through a lot of possibilities for a plan, right? A lot of driver combinations with orders, or a lot of like inventory, combinations. And those solvers have been around for a while, but haven't worked in like necessarily the tactical or real-time space without a lot of effort on the side of the user.
Got it. Well, I was thinking about our own journey, and we talked about managing fleets and distributing builds, and we started with the like simple is good enough, you know, and then we had to manage that, and then it got out of control. So then we sort of brought in we used like a third-party library, whatever, to manage some stuff, and then it got so specialized that we were back to like, actually, we need to be the ones, and it feels like it's this
that's almost
roller
exactly
coaster.
What people go through. It's like I say, it's like the manual to SaaS to custom, and that loop kind of happens with almost every decision. Yeah.
Totally makes sense. And then you said there's a very expanding field. Are there like, I guess, problem sets or spaces that have surprised you, that you're like, oh, wow, actually, this is the same problem, but it's really cool to see, or just that, that those folks have adopted and sort of said, oh, we should be much better at solving this problem.
Yeah. I mean, I think like logistics obviously has always been a big space for this because of the scale of problems that you're working with. So it's been really interesting to see the flavors, though, I would say, across like logistics, and like how many people are thinking about their logistics now. I think the interesting thing about, we started in 2019 and did Y Combinator in 2020, and we just saw like this explosion of people thinking about logistics because of 2020, like COVID, had things over, and the supply chain was, really, really strained. And so I think a lot of people took that as like, oh, wow, I really need to consider my logistics in a real way. And so that is everything from like schedules for their workers to like actual fulfillment of orders, and like, do I want to fulfill with one carrier, with many carriers? Like, people are kind of looking at it more as a portfolio optimization problem, which I find really interesting, rather than just going with like one wholesale provider. And like, you'll see a lot of people talking about this, especially in the like e-commerce and retail space, like not getting locked in with like kind of one carrier anymore. And so I think that's kind of an interesting dynamic that's kind of switched over, or even launching their own fleets, which I find really interesting too.
Yeah. Wow. I mean, the timing is really fascinating.
Yeah, timing is super
fascinating. The whole world became much more interested and aware, I think, of supply chain in the last few years. Yeah. Obviously, I have images of, container ships stuck sideways and like everything that just, that blew up as a result.
Yeah. And the other one that I also find interesting is sustainability. So we've been hearing a lot about sustainability in the logistics space, and people wanting to optimize more for sustainable KPIs or sustainability KPIs. And I think that's a really interesting one, because I fundamentally believe optimization is necessary for sustainability initiatives, because the core of it is trying to make your system more efficient. And the reality is, like, if you're leaving a lot of like slack on the table by making decisions manually, you're probably leaving a lot to be desired on the sustainability side also. So I think that's been an interesting one that we've seen too, is a lot of folks talking about EVs or like battery allocation or things like that. And yeah, like I think there's a lot to be said there, like all the way down to like literally the battery technology for optimization. So,
well, and I think even by ignoring for a second the goals, the sustainability goals maybe of organizations, just optimizing their logistics is good for
is
everybody,
already good
even
for
just like
exactly
fuel
like,
consumption and all these other things.
Where, Yep.
Oh, that's really interesting to think about. So, I guess where is all this going? And in particular, like we talked at the beginning about, Gen AI, and as you said, that kind of letting everyone in on the secret of AI. Like actually, this stuff does work. It's not just about machines taking over the world, but like there's all these different disciplines. Has that sort of accelerated the way that people think about these problems? And is there something that we're headed to now as a result of kind of all of this fanfare, in your space?
Yeah, I think it has. I think the nice part about Gen AI as a kind of buzz last year was the fact that it highlighted that these types of technologies are available to your business, and you should be thinking about how AI can impact your operational efficiency. And the thing that I want to highlight is like it's not, like, I think you said this at the beginning, it's like not a blunt instrument. Like there are many types, like so like you can pick and choose the type of technology that suits your problem, and I think that's like a really important kind of like next layer to the buzz that happened last year. But I do think it kind of highlighted for a lot of businesses that they should have an AI strategy, right? You should understand kind of what algorithms you're investing in, what areas of your business you're spending a lot of time on, and maybe where you can augment your human resources to work on higher level tasks. Because I don't think AI. I think there's been a lot of like fear that AI is replacing folks, and I actually don't think that's accurate. I think it's just changing jobs, right? Which is hard in its own right. Don't get me wrong, but I think it is just like allowing you as an operator to work on more strategic level tasks or more human touch necessary tasks, right? So on that care side, or kind of needing a little bit more love for exception handling.
Yeah, that makes a lot of sense, and I think I strongly agree. Like Gen AI it's not like it's gone. It'll still be the year of Gen AI this year, but it has really lowered the barrier to entry for people to say, like, to experiment and say, oh, this is a problem that might actually be helpful or could be helped, I guess, by the application of AI. But then realizing this is a very general tool. Maybe I need a more specific tool, right? Like I could probably get an LLM to make some decisions for me, but then I'd say, wow, this is really expensive and really slow. And really I have some very specific
that's actually
needs,
normally
right?
the problem, right? It's like a lot of tools can do the decision-making like across a variety of different domains, but they may not be as efficient at it in terms of like your SLA. And that might be fine for what you're trying to do. It just depends.
Yeah. Awesome. Well, is there another AI subset discipline that you're also really excited about that we haven't talked about?
Another AI subset discipline. I think I'm actually so I'm a little bit of a simulation nerd. I worked on modeling and simulation for naval projects at Lockheed Martin before going over to the startup space and then Grubhub. And I'm excited about capturing uncertainty in these decision-making systems. So I think kind of the combination of simulation and optimization tech is really exciting. And that's being looped into everything from like reinforcement learning to other types, right, of technology there. And I think that's really cool, because the reality is when we're making decisions as human operators, we're cataloging kind of like all those scenarios in our head, right? And trying to pick the best one based on our, own knowledge of that system and our own almost like estimates of that uncertainty. And looping that into like the codified version of these decisions, I think is really cool. And so that's like where a lot of the space is heading on our side is using that like uncertainty and optimization.
Yeah, I think what's really cool about that is I just want to call it the memory, right? Like, yes, every human is cataloging their experiences as they make a decision, but being able to consolidate those and actually have them stick through transitions of people and all those sorts of things. is something that, that data and tooling can do
Yeah.
that humans are not good at.
And learning from preference, right? I mean, like, I think like there's some interesting ways to kind of connect these technologies together. We've been talking a lot about even like the LLM side of it within our business. Like, how do you get people to classify their models faster, right, into particular types, or how do you help them pick solvers that are really efficient at solving those types of problems, or even there's been some papers on like how you actually use it within the search itself, right? And so I think that there's a lot to be said for how exciting that this industry is right now in terms of like the connectors. And definitely in my field, like as like a systems engineer, I think about how do you put these things together to make a system that operates the way you want, and you have the levers and controls as an operator of that system.
Yeah, I'm not going to go into that part because we'll be here for like another hour. But I think the whole
we can save that for next time.
how we take these models and integrate them into distributed systems, right? Treat them as services and then build systems around them, I think is a thing that we don't. Well, I mean, some people have ideas, but I don't think it's really clear. Like those patterns aren't established, and I'm excited for how that starts to play out over the next year or so as we move from like, oh my gosh, all this stuff is amazing. What do we do with it? And into what are the patterns of architecture that we apply?
Yeah, and like pipelines and like how do you think about these feeding into each other? Because in our space, like a forecast model feeds into a scheduling model, feeds into a routing model. So like how do you make sure that like kind of those data contracts, right, are well defined, right? And also like how do you test them? And so like that's something that we've been kind of looking at as well, giving better tooling around that.
Yeah. Wow. Well, I'll just repeat. What a time to be alive. Like a lot of things are changing in very cool ways. But we have a lot of the tools. Like we know how to build these things. We have all the pieces. We just have to remember to reapply them with this different tech. Yeah. And I will say every time I dive into a corner of this, space, I learn new things. And I'm continually excited about everything that's ahead of us. So thank you so much for joining me today. Thanks to everyone who's listening. If there's something you want us to talk about, someone you want us to talk to, find us on Twitter at CircleCI. If you enjoyed this podcast, obviously subscribe on your podcast provider of choice. And Carolyn, thanks again for joining me. This was awesome and very educational.
Yeah, thanks, Rob.
If you like what you heard today and want to learn more about building, testing, and delivering AI-enabled software, we've gathered all our best resources and tutorials into one place. Go to circleci.com/AI-ML to explore and start learning.